then it would have to subtract 1 to 4 to get the offset of 4. That subtraction takes time. Within computers, they simply decided that the easiest way of handling this was to teach the people who were writing programming that you start counting at 0, because they want you as a developer to count in offsets, not to count in indexes. So that means that an array that happens to have 5 elements in it, let's say these are 5 sums, okay, actually only contains offsets 0 through 4. So while it might be okay to declare an array this way, you will not actually be able to use the 5th element in this array because there are no 5th elements in this array. The maximum offset is 4. When you are using any kind of array or list-like item, it is very important that you keep in your mind whether you need to be using the offset to access it or whether you need to be using a count. The size of this array that has 0 through 4 elements is going to be 5 elements because 0 is an element. But when we start going through it, we are going to reference it 0, 1, 2, 3, 4, and then stop. This duality of offsets and indexes is the source of at least 30% of common programming bugs in C. So if there's anything that you learn from this class, learn when to use offsets, how to use offsets, and when to use the actual sort of natural counting indexes. And this will save you from a lot of grief. So here, range, we want 5 counted items out of range, which will give us offsets 0 through 4. It's a little strange, but after a while you start to think, oh, in this scenario, I'm thinking up to 5. Up to, and that's how you translate between a count and an offset. 5 elements means I count up to, but not including 5. All right. Now notice that this while loop is very similar to that for I in range of 5 loop, in the sense that if I run this while loop, I will get the same output. The difference is in the flow control. That while that for I in range of 5 will only go through the loop 5 times, whereas this while loop might go through it once or never, because this is a condition that is evaluated at runtime. Okay? That range happens to return back a constant list, a list that is not going to vary at runtime. Notice that I had to rewrite this program to demonstrate my example. Okay? As it is written, it is guaranteed to be exactly the same. You can often use different flow controls to achieve the same output. For example, I could have put down 5 consecutive if statements and add 1 to I each time. I highly recommend you don't structure your programs this way, but the point is that the outputs are a side effect of going through your flow control. And so multiple flow controls can achieve the same outputs. And here we are, we're talking about range. And so here he's using range can take an optional parameter. If you provided a second parameter, then it'll basically go in between these two. And conveniently, it will start at this offset and go up to, but not include the ending offset. There are various reasons when you do enough programming why this actually becomes more convenient. But for right now, just think of it as, who remembers like their old line number stuff from class school from way, way back when? Okay, so you'll know that like there's a huge difference between square brackets and the little curved brackets when you say something like this. And that's supposed to be a 5, sorry. And that basically means don't include the 5. All right? This is how you should interpret this. Including 12 up to, but not including 16. And if you're curious how you know this, you look up the documentation on range, and it will say something like starting index, and then they may actually use the word inclusive, sorry, to the ending index, and then they may actually use the word exclusive. Just basically means it doesn't actually include the last index. And so here you can see the output is 12, 13, 14, and 15. It does not include 16. The reason we do this is because this is really simple. If you say made an array of 5 things, then you could say range of the size of that array. And you'll guarantee not to walk off the end. All right. Stepping, it's sort of a weird place, but since they're talking about for loops, for each loops, the stepping basically allows you to control how large the step is between values. And so this would do 0, 2, 4, 6, 8, and will it do 10? No. Awesome. You've been paying attention. Now, if I change this from 1, what would the second value be? The first value that comes out would be 1 because we're starting at 1, correct? What would the second value be? Beautiful. Okay, we'll just blow through this real fast then. Weird stuff. Because it's an index, there are very useful shorthands that you can use with negative numbers. For example, we took our array, and I'm going to draw it a little bit bigger so the people in the back can see. So let's take our theoretical example of that 5-element array, which of course starts at 0, ends at 4. 1, 2, 3, and 4. All right? Sometimes it's really nice to refer to the last element. Some languages do this, some languages don't. Python does this. It uses the negative numbers to count indexes from the end to the beginning. And so if you're more interested in counting from the end to the beginning, you'll use a negative number. So this is basically indicating that, I'm sorry, this is a range function. This is not, that's how you do it if you're actually indexing an array. But this is the range function. So it's basically saying that it's going to count from 5 down to -1 by a step of -1. Yes?
So the forward indexes are 0 phased and the backward
Unfortunately, if the backward indexes were zero-based, there would be 2 zeros. And using 0, you would never know if you were referring to the end or the beginning. So yes, the backward indexes are 1-based, but usually you use them so infrequently that you're almost always worried about pulling the last element of a list. So the -1 makes a really nice, easy to write flag. Now, due to weirdness in computers, there are actually negative zeros in some number systems. Python will not use a -0 to indicate the end of a list. And nothing is more fun than using one of those systems and realizing that you've got a -0 when you meant to have a 0. Okay, so here we are, and so what we're going to do is we're going to read out 5 iterations through this loop, and every time we go through here, we're going to use the random library to select a random integer between 1 and 10. Now, knowing what we know about trailing numbers in pairs of numbers, would you expect 10 to be, just out of a guess, inclusive or exclusive? Very good. It would be exclusive. So this is how you actually pick a single-digit number, because it will never actually pick 10. And so here you've got 5 different integers, and apparently it picked a couple of them a few times. This introduces a key concept that's very important in Python, which is importing. You're not going to write your entire code in one giant file. You'll generally structure it in multiple files. Import pulls extra items in so you can use them in that file without actually having declared them within that file. Yes? So there's learning the language, which would be very much like learning how to express yourself and learning how the flow control and the contexts and how to type the language is. But then there's also learning the libraries that go with the language. And in doing that, some of it comes through just a lot of practice. Like, you'll probably become more familiar with the stuff inside the math library if you're doing a lot of math operations. If you're doing a lot of file operations, you'll become familiar with stuff in perhaps like if you're doing Excel files or CSV files, maybe you'll be using a library for that. You typically look up the documentation for the functions inside these imported namespaces. But you know, as far as knowing if there's a function that you need in one of those, a lot of times you don't. You wind up looking for the function using the internet or using Python's online documentation, and then it'll indicate that it's in a particular package that you need to import. And then you will import that package specifically to use that function. So when you import, if you just use this import keyword and the package name, you will import a lot of things. You will import everything inside random that could be used. This means that if you're using a IDE, I know that everybody was instructed to use PyCharm. So if you're typing along in PyCharm, who has seen PyCharm try to help you out and suggest the rest of the word that you were typing? All right. Who hates that feature? You guys have a lot to memorize. Okay, for a lot of packages, there's so many things underneath it that you don't remember all of the wording for it. And occasionally, once you get used to too many different packages, you can't remember the particular spacing or capitalizing or whatever it is that is needed to finish that out. So that auto-completion helps you program a little bit faster. All right? If you import a whole package, then this is an indication that anything underneath that package can be used. Sometimes you just want to import a particular function. All right? For example, rand int here. Okay, I'm pretty sure that Python has a rand float. I don't know what it is. I don't know what it's called, but I bet you it's underneath the random package. If I was typing RAND, I might see a suggestion that I might be wanting to use that because I have imported the entire random package. If I decided to limit my import and say from random import rand int, this is me saying I only want to import a specific function from this package and whatever else is necessary to make that work. But my program itself, if I'm not using the word rand int, then I'm referring to something that's not in that package. And so here is a perfect way of typing import random, because you basically say, from random, I'm going to import everything. Generally, you don't want to do that. You just say import random. But if you wanted to import just a specific module, then you could say from random import rand int, a specific function underneath that module. And then Python covers sysexit. Sysexit is a little controversial, but it's very important. It's a way of causing the Python interpreter to just stop and quit. The reason it's a little controversial is because if you get a program that's full of sysexits, it gets very hard to rationalize which part of that program stopped your program. You start having to put in debugging information and other things. So use it sparingly, but every now and then it is a really good idea to just bail out. And to do so, you would use sysexit. So we have covered all of the Python flow control. It's now 7 o'clock. The pizza's here. I would like you to get some food, and then we'll take a poll on whether or not we want to cover the practice questions, or if enough of you did the practice questions at home, maybe we'll just spot check 1 or 2 hard ones, and then we'll move on to the next chapter. Let's see how many of these practice questions here. First off, did anybody do the practice questions before coming to this class?
Is that the same as the exercises? Maybe they're different.
It's the same as the section at the bottom, the practice questions here.
There's something called exercises in the book. It don't look like that.
Well, the exercises are probably a different section. So, practice question. What are the 2 values of the Boolean data type? True and false. How are they written? Capitalized, correct. Not all capitals, just the first letter. All right. What are the 3 Boolean operators? Very good. Write out the truth tables of each Boolean operator in your own time, please. We can do it real fast. It's not that long. Okay, so here is the variable a. All right. And then that means that if this is, well, I guess I wrote it wrong already. So we'll say this is not. Here is a is true, and here is a is false. Okay? So not a is... Okay, fine. I am going to use T and F, because as soon as he said A prime, I realized my mistake. So when A is true, then this value is false. When A is false, then this value is... Okay, good. Fine, I'll do this. You'll get more than one truth table. Here's and. When A is true and B is true, when A is false and B is true, I heard someone say true. This is and. So they both have to be true, which just gives away the next question. When A is true and B is false, and when A is false and B is false, very good. Or. A is true or B is true. A is false or B is true. A is true or B is false. A is false or B is false. Very good. Various combinations of and, or, and not can generate any specific one of these items to true or false as you need. There are also other operations that combine them, but you don't have to worry about that for Python conditionals. All right? But if you start looking into truth tables, you might see things that are like NAND. You might go, well, what's NAND? NAND is the not of AND. Okay? You might see NOR. That's the not of OR. And you might see this one, XOR. Who can tell me what XOR is? Exclusive OR. Okay, fantastic. What do you think the truth table for an exclusive OR might look like? True and true, true XOR true? False XOR true? True XOR false? False XOR false. Right. Exclusive, only one of them. Whereas regular OR doesn't matter. Both of them could be true. But exclusive OR differs. Okay. Exclusive OR is important because you'll wind up with a lot of programming scenarios where you'll need something very similar to it. So the idea of an exclusive OR operation should not be foreign to you. All right. What do the following expressions evaluate to? Well, let's start off. Expressions evaluate from inner parentheses to outer parentheses, just like they do in math. What's this sub-expression evaluate to? What's this sub-expression evaluate to? True and false is false. All right. What's this sub-expression evaluate to? Not of that.
False.
Very good.
False.
Very good.
True. False. False.
Very good.
True. False. True.
Awesome. What are the 6 comparison operators? We kind of glossed over this in the recap, but I remember Evan covered it when he was going through the chapter in more detail. I'm going to spare you having to call them all out. Greater than, or actually that's less than. Greater than or equal, less than equal, equals, and not equals, right? Why can't you use these on Booleans? Yeah, there's no such thing. True is not inherently greater than false. It's just the only other value. Okay. Difference between the equal operator and the assignment operator. Let's start off with how do we write the equality operator? Awesome. That's for comparison. How do we write the assignment operator? What's the difference between these two statements?
Which is the variable value assigned?
Right. So basically, which one of these will evaluate out to a Boolean?
The other one.
The bottom one, because it's a comparison. And the top one, what will it do roughly? Correct, meaning that it will actually take the value that's currently associated with B and make that the value that is currently associated with A. What is a condition? It's an expression that could turn into a true or false value. Okay? When would you use it? Very good. When else would you use it? A while loop. Very good. Anytime that you basically need to do a control flow, switch. Okay. It says identify the 3 blocks in this code, which is horrible because I actually see more than 3 blocks. So, I'm going to highlight sections, and for this ease of simplicity, you tell me if it's a block or not. Okay, I hear a yes. It is not. It's not a block. It is a statement. But remember that if statements have a conditional, the keyword if, a conditional, and a block. So this whole thing is not a block. The print underneath it is. Okay? Is that a block? Of course not. You're not going to fall for the same trick twice, right? Is that a block? Okay, I heard yes, but actually it is not. This is just the complete if statement. The statement happens to have 2 blocks controlled by the evaluation of the conditional. Is that, including the P, a block? Absolutely. Likewise, that is. Is that a block?
Yes.
All right. Does this block have 1 statement in it? No. How will the statements be evaluated in this block?
Are you asking how will it separate?
Yeah. What's the flow control in the block? How will this block be evaluated? One statement at a time. Okay. So that means that this statement will be evaluated. Then this whole statement here will be evaluated. And then this third statement will be evaluated in it. Okay? Now, in evaluating this middle statement, we may enter one or the other of those blocks, but we won't enter both. Okay? My mouse foo is not very strong. Is that a block? No, I heard a no. It was faint, but it was correct. Is that a statement? Yes. Now, it's a statement that includes other statements, but it is a single statement because it is the entire statement of this if. All right? Is that, not including the identify at the top question, a block? Yes. All right. Write code that prints hello if 1 is stored in spam and prints howdy if 2 is stored in spam and prints greeting if anything else is stored in spam. I will simplify this. What kind of flow control construct do I need to do this? If, else, if, else. Okay? If spam is 1, a block that prints hello. Else if it's 2, a block that prints howdy. Else prints greetings. Okay. What can you press if your program is stuck in an infinite loop? Control C. Awesome. Okay, we didn't cover that in the recap, but Control C will basically send an interrupt to your program, and that should break it and stop its execution. Fortunately, nobody said the power button. What's the difference between break and continue?
Break jumps out of the block, continue jumps into it.
So they actually both jump out of the block that they're in. But the key is where they jump to. Yes?
Break will exit the loop entirely. Continue will just go to the next iteration.
Very good. So they both exit the block that they're in, but the difference is that, and because it's, maybe they can't all hear, break will take you out of the loop statement. Continue will put you back evaluating the next item in the loop, the next conditional evaluation. What's the difference between range 10, range 0, 10, and range 0, 10, 1 in a for loop? Actually, they don't even have to be in a for loop. Just what's the difference between them? Nothing. Okay? This one, because there's only one parameter passed in, it assumes you're starting at 0. What are the numbers in range 10? 0 through 9. Good. This one, you explicitly start at 0. What are the numbers in that one? Yeah. This one, you explicitly start at 0, and you explicitly increment only one value at a time. Again, 0 through 9. Write a short program that prints the numbers 1 to 10 using a for loop. Then write the same one that prints 1 to 10 using a while loop. Let's use range. What should be in this? 1. What should be the ending? 11. Colon. Okay. Print I. All right. Now let's do it with the while loop. I need something there. Okay, so we'll do less than or equal to 10. Thank you, sir. All right. Will that work? No. Why? There's a couple of reasons why. We don't know what I is. So this thing can never evaluate correctly the first time. So should I put, if I'm writing this I initialization line, where should I put it? Should I put it in line with the P on the print or in line with the W on the while? Okay. What should it start at? Very good. All right. Mm-hmm. Ah, you're right. It's not done. What will this do? Go into an infinite loop, printing 1 infinitely. We need one more thing. That's one way of doing it. For those of you who realize that there's a pattern of A equals A something, some value, a lot of times there will be a combined operator, which basically takes this operation here and moves it over to here in front of the equal sign, and then takes this value and puts it there. So this is the same thing as saying add 1 to A. Okay? Because adding 1 is so common, apparently we can't have enough ways of doing it. So this would also be adding 1 to I. Okay? As would that. Okay? The difference is when you're using assignment, and this will come up in any kind of basic programming question where the people are trying to figure out if you actually do know how to program. X will have the value in this case of I. And then I will have the value of I plus 1. And the reason why is because this plus is on the right-hand side. And it's shorthand. It's not actually implemented in any way that makes a lot of sense if you take a look at the instructions inside the CPU, but it's shorthand for I and then add 1. Yes?
In the IDE, just tried to print that out where it has R++ without assigning to anything, and it's giving me an error syntax error saying that I can't do R++.
You need to assign a number to R first.
There is no plus plus in Python.
Oh, there is no plus plus in Python? Sorry about that, guys. This is too many different programming languages, and one is intruding upon the other in my brain. So there is no plus plus operator. Forget about that. Continuing on with Java lambdas. No, no. All right. So if I have a function named bacon inside a module named spam, how would I call bacon after I imported spam? Spam.bacon, yes. Okay. I could also use the from and make bacon a top level keyword.
How about spam.asterisk?
It wouldn't know which one to call. See, spam.bacon, it's going to know to call the bacon function. But if I tried to call spam.asterisk.
No, but if you imported spam.asterisk, then you could call bacon without using spam.
That's true. Okay. So let's go to chapter 3. We finally got out of flow control, and now we're into functions. And the funny thing is that functions are actually also a key component of flow control. But the difference between function flow control and other flow control is that functions, you declare a block of code, and you bind it to a function signature, a name. So this basically defines hello to be this block, which is not very well aligned, but I believe all 3 of these prints are supposed to be aligned. And then it will print howdy, howdy, hello there. Now, down here where he uses this function, it will print these 3 items. And when the function gets used again, it will print these 3 items again. And when the function gets used again, it will print these items again. The main point of a function is you have defined some sort of block that you can now reference to it as a name. And so you've built your own hello name that you can use. Now, hello is probably not going to be something that you write a lot of in industry, but you might have a routine that says, checks to see if a server's up. And you probably don't want to type that code in multiple times. So you'll probably put that into a function that says something like check email server. in which case now you have a nice little handy function, and it's very expressive. It tells you what it does. Always try to look for names of your functions that tell you what it's used for, what it does from a user's point of view. Don't try to use names for functions that talk about how the function goes about it. I didn't, for example, say check email server by saying open up a port, send a message, and see if the email server responds. Because this gets too into the details of what is happening, and it doesn't summarize the information. This makes it harder for you to actually maintain your programs because you wind up never summarizing anything. It's sort of like, what did you do today? Well, first I woke up, then I pulled the bed sheets off and I stood up, and then I took about 8 steps forward to clear the bed and took a left-hand turn and about 12 more steps to go into the whole, after a while people will lose the train of thought of getting ready for work. The whole point is that you want your functions to give the right amount of summary. They want to be something that I can look at. It's like, should I use this function? I don't know. Do you want to check the email server? You don't need to know the details in the name. Okay, so how do we create a new function? Well, we've kind of gotten ahead of ourselves. We use define, the def keyboard. And so this def and this colon and this block all combine to make a function declaration, and it will take this hello, and whenever you use this hello, it will execute this block. So you'll notice something about the format of this hello. It has an open and closed parenthesis. We've seen this before. We've seen this before even in the print. The print has an open and closed parenthesis. This is a common pattern in Python. That's because print is a function. When you print something, you're just calling another function. It's jumping into another piece of code somewhere, and it is performing the low-level operations in order to get some text onto the screen. This item that is passed inside the print is called a parameter. It's a value that is passed to the print function. That value is the value that will be echoed to the screen. This hello, you'll notice that there's something missing there. And that's the stuff in between the parentheses. This is an indication that this hello function takes no arguments. So when we're starting to talk about the functions, here we can see the output of the 3 calls that we had mentioned before. Hello, hello, hello. It prints that block it runs through that block 1 time, printing 3 lines. It runs through that block a 2nd time, printing 3 lines, and it runs through that block a 3rd time, printing 3 lines. We could have, remember that flow control is about making your programs easy to understand and easy to rationalize and easy to structure. You can almost always get the same output with a different flow control. Here is a program that doesn't have the hello function, but produces the exact same output. What do you notice about this program that you see different in the hello program? Repetition. A lot of it too, right? So what if I decided that I was going to make sure that my program didn't have any colloquial phraseology from Texas? I needed to strip my program of all of its howdies. Which one would be easier to update? The first one, because I just changed one howdy. And everybody who uses my function will get hello without howdy. Sad world it may be, but still, it's easier to maintain. Now this one, which happens to produce exactly the same output, where do you think the dangers would be in maintaining a program written like this? Without going into any of the 18 N words.
So you might change one or two of them, but not all of them.
Exactly. Especially if my program is written this way to where I am actually repeating many times the actual text, I might not even be able to get them all on the same screen. I'll probably hit a few of them, and I'll probably miss a few. So there's a general value in programming. And when I say a value, I'm talking about, like, you know, we value honesty more. Well, okay, some people value honesty more than lying. Or, you know, we value elegance more than being, like, really sloppy. You know, some people have different values, and their values are, by definition, different. In programming, it's generally a good thing if you avoid excessive repetition. So who has ever programmed outside of Python? Okay. Now, all of you people, if I see one of your hands go down, who has ever cut and paste code? We all value not repeating ourselves, and yet cutting and pasting code is the definition of repeating ourselves. There is a time and a place for it. It is driven by economics, okay? Sometimes it's more expensive to go back and try to rework everything to use some sort of a generic solution. And so you cut and paste something and you change one value. What happens a year later? It's harder to maintain that program. And if you've cut and pasted a lot, it may even be nigh impossible to maintain the program. Point is that these kinds of trade-offs that you make between, say, efficiency of getting the solution out now and your ability to maintain a program later is going to determine how people view you, but they're not going to determine how people view you now. They're going to determine how people view you later. Today, you might go fast, but tomorrow you can't, because now there are too many copies to update and too many copies to check and too many things that you've got to make sure all work with the new data structure or the new paradigm or the new interface or the new API. So it's very difficult, but generally, if you can find a balance where you go slow enough to not make a big enough mess, you can actually maintain a higher speed over the course of the application. And where that comes in is primarily a function of experience. So here, as you get more programming experience, if you were not careful with your cut and paste, you will spend a lot of time deduplicating code. Because deduplicating is a fast, fancy way of saying undoing the cut and paste. And doing it the slow way, you should have done it the first time. But that said, it's all about readability. Occasionally, you will parameterize something, and you will parameterize it so well that you no longer even understand what it does, because everything that goes into it is a parameter. Try to find a happy balance. All right, so here we go. When we call print or length, you pass values into it, right? So when you pass values into it, you need to define your function a slightly different way. You need to define it with some sort of way of referencing the value that you passed into it. And so what you do is and this is horrible because they picked absolutely the wrong variable name for this, but you put a name in your parameter list. And this is probably one of those horrible inside jokes, but really what I would say is something like, I would have said, hello, user, and then print, hello, user. Because even something as small as that is more descriptive than name, because a name can be a name of anything. Whereas this, at least you get an idea if it's a user. It might even be more descriptive to say person or first name. First name, I think, is a winner. Never be afraid to take a few moments to try to rename whatever it is that you're doing to make it easier to understand in the future. This will maintain the usability of your programs longer term than anything else. And picking a good variable name can be difficult, but take the time to do it. So here, if I say hello Alice, what will happen here? Has anybody pre-read this chapter? Okay, I saw about 6 hands go up. Someone who did not raise their hand, what do you think would happen with hello Alice?
It will say hello, Alice.
It would say hello Alice. Do you know why? This value would be bound to this variable called name. So in the execution of this hello function, it would say hello and the value inside name. And so it would say hello plus this string of Alice. In Python, when you do one string plus another string, it sticks them together, concatenation, makes a big long string out of it, and it would print hello Alice, just as it does right here. Now, that Alice is not somehow permanently fixed to this name. It's only fixed within the context of this first line next to 3. When you reuse the function with Bob, name will be bound to the value Bob, and you will print out hello Bob. And so when you run this program with hello Alice and hello Bob, you get 2 different outputs. Because the first time, name is bound to the string Alice, and the second time it is bound to the string Bob. Okay, and that's what they just said there. So if you ran hello Alice up here, all right, and then you ran hello Bob and it printed out Alice again, then that would indicate that somewhere along the way, the value Alice was retained. It is possible to write functions in such a way that you wind up retaining values in various locations. You could say inside the body of the function, store the string in a database and pull it out later. But you can't do that with this example, okay? And so what would happen is they're trying to emphasize the scope of the binding, how long this name holds the value passed into it, is determined by the function itself. Once I leave the block of the function, name does not have a value. Matter of fact, once I leave the block of this function, the variable name does not exist. It is created for the scope of this function, and it is lost as I leave this function. In between this hello Alice and hello Bob, if I say, what is the value of name? The correct answer is, there is no name, because there is no name at this scope. So working through, how do you use a function in such a...
It's fair to ask, where does name, where does it reside? Where does it hide? Because next time you call the function, you're going to give it an argument, and that argument is going to go looking for the variable, right?
That's true. That's true. And we'll talk a little bit about the scoping, but for right now, I'm going to simplify it and say that in our def hello first name, you can sort of think of it as before this block is created, it adds a variable name, first name here. And then as you're leaving this block, it destroys that variable. Okay? And so that variable only exists inside the block. So when we're calling hello down here, you're not in this block in between the two lines. The way that flow control works for functions is you enter this line, and this line jumps to execute the block of the function, and then it jumps back immediately afterwards. So you're not in this block in between the lines, the two hello lines, but you are in this block while you're processing this function. Okay? Does that make it a little?
Yeah, yeah.
Okay, fantastic. Yes?
So the parameter is always string type? The parameter passing is always string,
No.
or the default is string?
Neither. So Python is strictly typed, but it is not. Oh, good. Wait, I keep getting this backward. Evan, spot check me on this. Python, the variables are, the values have types, but the variables themselves don't enforce the types. So is that strict or strong?
It is said to be a strongly typed, dynamically bound language.
Fantastic. Thank you. So basically, the variables have types. The variables have types. I'm sorry, I'm said it backwards again. The values have types, but the variables don't restrict a particular type. So there is nothing inside this hello first name that forces me to pass a string. I could pass a number to it.
Right, but it will treat it as a
No. No, it'll treat the number as a number, and then I'll probably get an error when I hit down to the print part.
Does that answer the question?
Okay. Numbers put out of, did numbers promote to strings? I can't remember. Okay, so the concatenation operation will fail, and then, yeah, okay, there you go. All right, so now functions are interesting, but there's very few times when you don't. There's something that happens a lot where you need a value. Like you'll have a function to look something up in a database. Maybe you'll do it by like an ID or a first name or something like that. And you'd like to get a value back. Okay, when you get a value back, there's a special keyword that's related to Python functions called return. So much in the, I keep losing my eraser. So if I define a function, I could do something like, you know, search the database. Database. And then I can basically decide that I want to return that record back. Return means that when I call this get user, the evaluation of this function call is effectively going to be replaced with the value that is returned. So if I wanted to create a function called add, and it will take two variables, a first variable and a second variable, and I say return first plus the second, then what will happen is it will perform this math operation here, adding these two values together, and then it will return the result of that. So that means that I could say something like x equals add 3, 5. When this gets evaluated as a statement, it will try to figure out the value first on the right-hand side of the assignment operator. And this 3, 5 will jump into the function. Here, it'll be 3 plus 5, so it'll be 8. It'll return 8, and it's going to effectively say that the value of this entire add operation is 8. And that will be the value that comes back from add and is assigned to x. So functions that evaluate out to a value have return statements in them that return the value that, is produced through the evaluation of the function. I know I'm stepping over my tongue here and trying to describe it. Does anybody have difficulty understanding this concept? Okay. If you do, by all means, go on to Discord, pull one of us aside or something, because this is critical for people who are not used to programming. So here's import random, and we've defined a function, get answer, and we've defined a parameter, answer number. And if answer number is equal to 1, then we say it is certain. If it's equal to 2, decidedly so. 3, yes. 4, reply hazy, try again. Who's ever used a magic 8-ball? There you go. It should look familiar. Concentrate and ask again. My reply is no. Outlook not so good, very doubtful. Here we use the random int function to get a number between 1 and 8. Remember, 9 is not included. And then we're going to pass that number in to get answer, and then we're going to print out the fortune. And so the main idea here is we don't know what number we passed in to get answer, but that will become bound to this answer number. And then as we compare the answer number through this very large if-else-if statement, we will eventually trigger on something, hopefully, and return back a string, being the famous printed side of the magic 8-ball. Then we will print that. Okay, so I talked you through it, so I'm going to spare the reading of the talk through it. And what we want to focus on is this R here. R is the argument of the function. Now, some people say, what's the difference between an argument and a parameter? And it's really the point in time in which you're considering the same thing. An argument is a value that's passed into a function, okay? And a parameter is the name that will be temporarily assigned to that value. That said, people are very sloppy in their language. And so they will say something like, oh, yes, I passed R as a parameter. Well, actually, I guess that's still technically correct. But sometimes they will say, oh, it took the parameter R. Okay? You will just have to understand that when you're passing something to a function, you're not passing the variable R. You can't get the text R interior to the function. It doesn't exist in that scope. Instead, what happens is the value is rebound to answer number. Okay? Now, if I had put that R in quotes, then that would have had a value of the string of R, and the values get passed through to functions. So values get passed to functions, and so if you pass a variable into a function, it will resolve the value of that variable and pass the value. But it won't pass the variable name. You understand that?
So a parameter is just a name. Right? It's not really like a value, it's just the name of a value.
A parameter is a name inside the scope of the function. So this get answer has an answer number parameter. Okay? But it's not the name that somehow is really being passed, it's the value. And to reference that value, you will use this name inside the function. And when you're outside of that function, it will be whatever you passed in. It could be an actual typed value, or it could be a variable. Yes?
Can you say that the parameter is part of the definition and the value is part of the call? That is, the argument is part of the call?
You have the right idea. The parameter is part of the definition, but there's a lot of, and I hate to use this word because it's overloaded already, but okay, I will use a different word. There's a lot of discussion as to what to properly call the thing that is pushed into it. Okay? Managed to dodge using the word argument. Okay, so here it's saying the get answer is called with R as the argument. Okay? Which inside that, it will find out the value of R and it will bind it to a parameter answer number. So this R right here is a variable, and it was defined in order to hold the random number. You don't need intermediate variables. Sometimes they're very useful, and sometimes they're not. In this case, the variable R expresses nothing to me as a human being, except that it's a letter in the alphabet. So I would probably write it as get answer, taking the value passed from this function and just passing it directly in as a parameter. All right? However, if you start doing a lot of these, sometimes it can get pretty hairy. This is to print the get answer of the random number. All right? When those lines get too long, occasionally it's nice to know what a value is somewhere in between all of the passing of these values to these nested functions. In that case, pick a better variable name and then hold it as an intermediate. But I do see this programming style crop up a lot where you define a new name to hold every return value from every return function. Here you run into the other problem of now you have 500 names and you don't know what they all mean because you can probably only remember about 6 or 7. Okay, so try to make sure that your functions, you know, your routines within any page, you only need to remember like half a dozen variables and it'll be easier to maintain over time. The none value. Who's programmed in a different programming language than Python? Every now and then you have a value that means nothing. Okay? In Python, this value is none. None is not a string. None is not a number. Famously, C decided to use the number 0 to mean nothing in a lot of cases, but unfortunately it also means 0 in a lot of other cases. Python sidestepped all the bugs you could introduce doing something like that with a new value called none. All right? So, an array that doesn't have anything stored in it is not exactly the same thing as no array. None is a very distinct value that indicates the absence of something. Okay? So, when you do not return a value from a function, that function actually still returns a value. It just returns the none value. And so what they're showing you here is that print, it doesn't have a side value to return. Its side effect is displaying text to the screen. It's not going to actually return a value like our add example does. But you can still capture the not returned value, and that means that spam will hold the value none. Okay, this makes it a little bit easier. Like if you ever worked in a programming language where they actually had a keyword that you couldn't capture, like Java has void. And if you try to assign a void function to a variable, it'll say like, no, this function doesn't return back a value, and you get an error. That limits some of the kinds of programming that you can do. Python's slightly more flexible in this way. It'll just return back the none value. Which means at the end of every block, if it's not written there, you can kind of deduce that it has an implied return none, or every block inside a function. So keyword arguments in print. If you ran this program, by now I know that you've gone through enough examples, you know exactly what this will print out. All right? However, Python has optional arguments that are named. They are called keyword arguments. They are not handled the same way that positional arguments are. So when we talked about like range, we had two numbers. One number came first, the next number came second, the third number came third. And these numbers meant different things based off of the position inside the parameter list. Keyword arguments bind to keywords. That means that if I moved this end before the print, things would still work, and it wouldn't actually change the value. This end is a keyword argument. Have you ever noticed that in Python, when you print something out, you get to the next line? If you print out two things with two print statements, you're down to 2 lines. Sometimes you want to stay on the same line. This end overrides the new line that drops you to the next line with nothing. So it will print hello and then nothing instead of hello and then a new line command. So here, printing this hello with a non-default ending, and then the world combines these two to hello world with no space. Now, if I put a space in here, then it would be hello space world. And if I put a comma in here, then it would be hello comma world. And if I put a new line explicitly in there, then it would be hello and world with a new line in between, so they'd be on 2 different lines. Okay? Now, you wouldn't need to put a new line because keyword parameters often have default values associated with them. This is the reason why they just work really nicely together. This is the reason why they're keywords. You don't have to override the default value. End has a default value of new line. So here, one thing that you may or may not have done, I'm not sure, is who has ever printed out 3 strings separated by commas, or 2 strings separated by a comma? Okay, what happens, generally speaking? Right. You get a space between them, right? Okay. Of course, if you replace these with plus, it would combine all those strings to 1 string and then just print out the 1 string. But if you've got commas in here, it prints them out with nice little spaces. It makes it really easy to print out lists of items. That's because there's a separator keyword that has a default value of space. Assuming that you want commas in between these items, you can override this separator keyword to be the value comma. And so in this case, it would print the same thing that it printed before, but now it is printing out commas as the item separator.
And you could do comma space.
I believe you can. Okay, so this keyword idea is going to have an impact. When you decide that you want to write a new function, you will use what keyword in order to indicate you're starting a function? Def. How do you end the signature of the function? A colon. Okay, so the function, def function name, open your parenthesis, your parameters, close your parenthesis, colon, what goes underneath that? A code block. Very good. Now, when you're defining those parameters, you will find, as we move on, that you can also define your own keyword parameters. These are not special things. You can write your own functions with keyword parameters. But before we talk about how to write keyword parameters, we're going to talk about scope because, of course, I would introduce something in a little bit different order than they're talking. We went over this in perhaps too much detail. So I'm going to call them up with a function, and I'll call it, I don't know. Give me a name. A name?
Foo.
Foo. We'll go with foo then. Foo bar baz. Okay. And so here's my function foo, and here's my block. Okay. And it's basically just going to print whatever I passed in. Now, we talked about how long this variable a exists, right? It exists within the scope of the function. If I did something like a is 5, I define well, here, I'll define the foo up front, and then I'll say a is 5, okay? And then if I say foo a, this is confusing in some ways because I'm using the same name as is inside this scope. Okay? But actually what happens is the value of a is extracted here and the 5 is passed and then rebound to this variable up here. So this a is not this a. This a is confined to this block. This a is confined to this block. Just because it's a function call does not mean that the variables from this block leak into that block. All right? Now, there are some exceptions, but we'll get to those. So let's do this.
You could, the 5 could not get into the depth. I'm sorry, I don't know how to ask the question.
No problem. Maybe it'll become clear in this extra example. Here, there we go. If I pass 5 in through here, there, that should do it. If I pass 9 in here, in this block, I'm calling foo, right? What will the value of a be? 9. What will this operation do? Set b equal to 9, and then it will print 9. And so if I come back down here and say print b, what will this print? 5. Because this b is scoped within this a. It is not the same b as this scope. Okay? Because when I'm thinking about writing this function, I don't want to have to scan my entire code base to find out if I already used that variable in some module somewhere, maybe even in something that I have not imported yet. So the reach of this variable b is only within this block.
What if at the very top of the file you had a b equals 0?
You actually have to declare inside the block that you're using the b outside the block with a keyword called global. Okay? Which is, surprisingly enough, the next thing that they talk about. So local variables cannot be used in the global scope. Here they define 31337 to eggs, and then they try to print eggs out in a higher scope. This won't work. Why? Exactly. Egg only exists within the scope of the spam function. So this means that this will say, hey, I have no idea what variable you're talking about because that variable doesn't exist at this scope. Okay? And so here, when he runs it, it says, hey, you're trying to print eggs, but eggs isn't defined. It is defined within the spam function, but it's not defined within the scope that you're trying to print it at. So local scopes. Cannot use variables in other local scopes. I didn't go over this, but basically if you have two functions, here we've got spam where we set eggs to 99. Here we've got bacon where we set eggs to 0. All right. This setting eggs to 0, this eggs is defined in the scope of bacon. So it's not just about global scope and function scope. This eggs does not exist in this scope as the same variable. This eggs is local to bacon. This eggs is local to spam. When we get to this print eggs, which eggs do you think it will print? The 0 or the 99? The 99, because as soon as this one is set to 0, we leave bacon. This variable scope gets destroyed, and we're back into the spam scope, where completely different eggs, just happens to coincidentally be typed the same, exists. Global variables can be read in a local scope. Okay? So in other words, here we've got this function spam that prints eggs, and eggs, as you had mentioned before, at the top scope was set to a value. And you can read it. However, if you try to set it, what will happen? The syntax of Python's assignment operation will declare an eggs local to the scope of spam. So you don't actually wind up setting it in the global scope. Instead, what you need to do is to make that work in the global scope. You need to add the global keyword, and that's an indication that when we assign, we're not assigning in our scope, we're assigning in the global scope. Now, I kind of went through these sections pretty quickly, and so I'd like to know whether or not I lost anybody, because we can go through the examples in more detail. And if you say nothing, we will go through the examples in more detail. Yes?
I mean, is there a legitimate reason to do this, to bother with the global scope? I mean, there might be legitimate reasons, but would you do it?
So this is a controversial topic. Generally, global variables make things much harder to rework over time because the global variables act as like silent communication channels between the different parts of programs. But occasionally, global variables turn out to be really useful. For example, if you say, had a function that loaded a database driver, you probably don't want that database driver that you just loaded from disk to be gone as soon as you left that function. You might want it to hang around for the next time you tried to call the database. So they may have like a table of database drivers held in a global scope. And so the second time that you go and access the database driver, it can find the side effects of the previous call. Now that might be one example and probably a better example of when to use a global scope, but there's no reason to write your program that way. You could quite easily have had the load driver return the database driver code or whatever, And then you could have easily registered that with another function call. Okay, there's no need to structure your code a particular way, but occasionally some of these patterns come up. If you want a good maintainable program, do try to avoid variables in the global scope, unless it just rationally doesn't make sense to do otherwise. So here we are, and we're going to do some horrible things with spam, eggs, and bacon because it's the old Monty Python spam, 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 and more spam skit. But the point is that here he's saying that eggs has a bacon local value and then prints, and then he calls spam, which has a spam local value and prints, and then he has a global value. And so when you say bacon, then bacon prints bacon local, then it goes into spam, which will print spam local, then it'll print bacon local again, and then it'll print global. And here we are with the global statement where we basically say, no, we're actually changing the variable at the global scope. So you can go through the rules. If the variable is being used in the global scope, it's a global variable. It can be read from inside functions. It just cannot be assigned. Okay? Unless you use what keyword? Global. All right? So let's keep moving through. Now, who can tell me why this doesn't work? Exactly. At the first time that you attempt to use spam, then what's going to happen is this print statement, as it's being evaluated here, you have no variable eggs. It's not a parameter that's passed through. It doesn't know when you're defining this function that eggs is going to be declared later on as a global. So you run into problems of order of loading. This is another good reason to avoid globals, because it basically means you have to restructure your programs in certain ways that you can find the globals within the functions. Passing the items through the functions is a lot easier. All right. What's the only number you can't divide by?
0.
Do computers change that? Nope. So when you divide by 0, what do you think a computer should do?
Return out a number.
No one has decided yet. Okay? Some people might argue you should return not a number. There have been a few people who have decided it's easier to return some sort of a symbol that indicates an infinite number. There are a few people who decide that it's a good idea to just stop the execution of your entire program and dump core. And then there's a few people that basically decide to come up with some sort of error handling routine. Python uses exceptions. Who does not know what an exception is? Okay, good. An exception is a condition in your program which really generally should not happen, or happens so rarely that you should never really account for it all the time. Exceptions are unusual in the sense that exceptions in Python have a different flow control than all of the stuff that we've talked about before. Exceptions interrupt normal flow control. And you do this through throwing an exception. And there's a throw keyword. So right here, here's divided by. And this little divided by function, or the spam function that divides by, has a subtle problem in it. And since we've been talking about division by 0, I'm pretty sure you know what the problem is. What happens when I say spam 0? Depending upon how deeply nested it is in your critical enterprise application, a black hole may swallow your heart. Unfortunately, your body will still exist to finish debugging the program. It's going to basically not be able to perform this operation because this operation is not permittable within the realm of mathematics. And so it will throw an exception. And you will get this very interesting divide by 0 exception. So this is what it looks like when you divide by 0 in Python. And you'll notice this 0 division error, division by 0. And it'll very conveniently be processed by the Python engine, the parts of the Python engine that are still running. Your program won't be. And display sort of the rationale of where this exception came from and how it bubbled up to eventually stopping the program. And so you can see that it says basically most recent call last, because for usually you're more interested in where the exception ended initially. And so it'll say, hey, you tried to do this, but inside this, that's the line that threw it. And so it'll talk about where it got caught and where it originated and how it trickled up through all of the function calls that are nested all the way down to the thing that raised the exception. And then it'll give you a nice little printout of the exception. This is the exception name, and this is some sort of descriptive, helpful text. And so one of the things that you can do, though, is you can actually prevent your program from dying. You can try things. And try is an indication that, yes, you do want to do this, but if it doesn't work, you don't want the entire program to stop running. And when you try this, then what you do is you use a new kind of handler that handles this exceptional flow control. And so we're going to try to divide by 0, except if we get a 0 division error, then we will just simply print, you gave us an invalid argument. And it won't crash the program, and we won't get that stack trace. So here, this call will print out 21. This call will print out something, well, I guess 3. And then this call will print out error invalid argument. Yes?
But you're not returning a string. There is no return value. So is it print none?
Well, it'll print out first because the exception got caught. Error invalid argument, and then it will print out none. And then this one will print out 42. And that's because you're right. Every function returns back a value, even if that value is none. And so as it catches the divide by 0, this print happens. And then this thing can't evaluate out to a proper return value because it can't perform this operation. It'll hit the end of the block and hit that implicit return none. So 21, 3.5, invalid argument, none, 42. All right. Now, that's how you would catch it if you're trying to catch it inside this function. But there's no need to catch it just inside that function. You could catch it somewhere else. Remember, it's going to bump up through all of the calls until it gets to the top, and then it'll crash your program. So you could put the try around the prints. And what will happen now is it'll print out that 21, that 3.5, and then at this point, it's going to throw the exception And when it throws the exception, it falls into this try except statement, and it will cause print invalid argument. And because you exited this block, this line, into the exception block, it will not print the handling for spam 1. Matter of fact, it won't return a value back here because it's actually going to die in the call of spam 0 before it even gets to the outer call of printing that return value. So in this case, there is no none. Can you see that flow control there? It completely violates all of the flow control statements that we've studied before. It's not a loop. It's not a conditional. It's not a function call. Instead, what it does is it uses an exceptional flow of throwing an exception until it bubbles up all of your nested function calls and is either caught by the top level Python handler or caught by an exception handler that you provided somewhere between the exception and the top level handler. If it's caught by the top level handler, it will print the stack trace and exit your Python program. All right, number guessing games. This is who's ever programmed this in any language before? Awesome. Okay, I see about 20% of the class, maybe 15. Who really wants to cover this one?
You're standing up. I think you volunteered.
Fine. So this is the game that we all played as kids. I'm thinking of a number between 1 and 37. No, you need to guess higher. No, you need to guess lower. Basically, you use random, or in this case, use random to pick a number between 1 and 20. You ask the player to guess 6 times, which basically means that we're going to use the range operator, and guesses taken will be the guess number. Print, take a guess, read the input. Inputs come in as a string, so we need to convert it to a number so we can basically do the comparison correctly. Is the guess less than the secret number? If it is, your guess is too low. Is the guess higher than the secret number? Your guess is too high. Otherwise, let's exit this whole guessing loop. At the end, if we got out of the guessing loop and the guess happens to be the secret number, print, good job, you guessed my number in so many guesses. Otherwise, print, nope. The number I was thinking of was, and then you spill the beans and tell them your secret number. Now, remember, we want to add a number to the output. The output is a string, okay? But because we had to do numeric comparisons, guesses taken is an integer. So we use the string conversion function in order to convert that integer into a string so we can add it to this string and display it correctly. Okay. I just told you everything that it said, except that it's going to read it to you in English again. And it didn't even show you the example input. Okay, well, some of the things you can do. You remember how I said that breaks can sometimes make your code harder to rationalize about? This 4 guesses taken implies that we're going to give them 6 guesses, right? Right. This break, it just sort of stops. No, it's just sort of like it just breaks out of this loop. And so like later down here, we've got to put a lot of logic around Did they get the right number? Did they not get the right number? What's another way that you could theoretically restructure this for loop that would actually express whether or not you're leaving for one reason or another? You could put something about actually comparing the number to the secret number in the loop. Okay? Matter of fact, you could just say that it's for the guesses, and then instead of having this down here at the bottom, just slip that into the bottom. If you guess the right number, then you could basically say, while incorrect and guesses is under 6. Okay, under 7, because you don't want to give them just 5 guesses. But the point is that doing that, sometimes if you put these conditions into the loop, it makes it easier to understand later under what conditions you're supposed to be leaving this loop. So while you could leave the loop early through a break, it sometimes, when this loop starts taking up this much of this screen, it's very easy to get these loops to expand very long. And these sort of exiting things can sometimes make your programs harder to maintain. Okay, so that's the guessing game as they wrote it, with a hint on how you might rewrite it to maybe even make it a little bit more readable for later. So let's see if we can recap this real quick, and then we're done for tonight. So why is it advantageous to have functions in our programs? Simplified code. What's that? Avoid duplication. Yep. Both of those are excellent reasons. When does the code in a function execute? When it is called. All right. What keyword? Okay. What's the difference between a function and a function call? Exactly. A call is something that only exists at runtime. You can define the functions all you want, but they will not actually execute until they are called. How many global scopes are there in Python? Yes. Sorry. How many local scopes are there? As many as you decide to create. Yes. Not in Python. I don't believe there is. JavaScript there is. In Python, I don't believe so. I think it's just global and local. I don't know. I've never used it, but I thought Python only had 2 scopes. Evan, why don't you Google that while I continue through? What is a return value? Okay. All right. I heard at least 3 correct answers and then 3 answers over each other, so I don't know. Basically, if you're thinking about like replacing the function with a value, that's what the return value is. If calling a function with a certain set of parameters means that it would return back a certain value, that's the return value. Okay, what keyword do we use to indicate a return value should be passed back to the caller? I know, it's terribly circular. How can you force a variable in a function to refer to the global variable? Global keyword. If you don't have the global keyword, you have to rely on the global variable being used before or after the function? Before, because otherwise the function will think that it is an undefined local variable. Can you set it without the global keyword? Can you set a global without the global keyword? No, if you set it without the global keyword, then it'll actually set a local variable. Global keyword is what gives the function the idea that you're not looking inside the function. You're not creating a new variable within its scope. The global keyword will indicate that you're actually intending to manipulate it at a higher scope.
But if you set it outside the scope of any function, it is not then in global scope. If you set it not inside.
Yeah. If you're not in a function, then worrying about how the function reaches outside of its scope doesn't matter because you'll never be in the function.
So that variable would be a global variable.
Yeah. So like if you had at the top level scope something like age equals 6, and then you decide to set age to 7, there's only the global scope here. So there's no local scope to consider. All right. So none. It's the value that means nothing. All right. What's its data type? Very good. We didn't even cover that. All right. Let's import all your pets' named. All your pets named Eric. Statement due.
Enforce the module or all your pets named Eric.
Yes.
It's a very poorly named module.
It's probably an inside Monty Python joke that I don't know.
I don't recognize
If they'd said something about dead parrots, I would have been spot on, you know? All right, if you had a function named bacon and the module named spam, wait a second, is this like a repeat? We already covered this. Exact one. Okay, skip it. How do you prevent a program from crashing when it gets an error? Try exception, okay? What goes in the try clause? And that's typically wrapped in I'm looking for a word that starts with the letter B. A block, okay? What goes in the accept clause? Which is typically, the way that you handle it is typically wrapped in a block, okay? Except that the accept clause also has a name to allow you to reference the exception. So you'd say accept some name, and then that way you could use that exception inside that handling block. Okay. We are going to skip the programming assignment because that'll give you something to do this evening or tomorrow or whenever. And thank you very much. So we'll pick up again, and we'll pick up on wrong window. We'll pick up on lists. So we're going to try to cover two sections. So it might behoove you to read both lists and dictionaries in structuring data.
Thanks, man.
You're welcome.